So here the next point is each interior angle of a regular polygon. So what about regular polygon here? Regular polygon is nothing but a polygon which is having all angles are equal, and in the same way all sides are equal. Okay, all sides are equal and all angles are equal. We will call those polygons are regular polygons. Okay, so here each interior angle of a regular polygon. Previous we discussed that sum of all interior angles, sum of all the angles. If you add that all the angles, you will get some result, right? So that one how to find, already we learned that. Now here my question is how to find that each interior angle. Why I am saying that each interior angle means in a regular polygon all angles are equal. So each angle is equals to how much? How we can say? Okay, for example here in an equilateral triangle, okay, all sides are equal, and here we are saying that all angles also equal. Okay, and here we know that each angle is equals to 60 degrees only, no? Here each angle is equals to 60 degrees. Why? Because here all sides are equal and all angles also equal. Okay, this is an equilateral triangle, that's why all are equal. Equilateral triangle is an example for regular polygon. Yes or no? Okay, so that's why here how we can say that here 60 degrees. Okay, clear. In a quadrilateral each equal angle is equals to 90 degrees. But what about that pentagon? Do you know that? Each interior angle of a regular pentagon, we can't say. We can say, but here directly without using that formula we can't say. If you know that answer, then you can say that. Okay, but here this is a 60 degrees, 60, 60. Okay, that is equals to, totally equals to 180 degrees. And here 90 plus 90 plus 90 plus 90, 4 angles, 4 equal angles. So which is sum is equals to 360 degrees. What about that pentagon? What about that regular hexagon? What about that regular any other figure? If that figure is consisting 100 sides and that figure is number of sides is equals to number of angles, no? So that's why if that figure is having that 100 sides and 100 angles, then that figure is a regular figure, and each angle is equals to how much? Okay, then how we can find? Okay, it takes too much time, right? Like this way we can find. So in that cases we can use that formula as 2n minus 4 into 90 degrees by n. Why here we are taking by n means here all angles are equal. Okay, so let us see that proof. So here the proof is let theta be an equal angle. Theta be an equal angle. Okay, so how we can say that theta be an equal angle? Okay, but what about that sum of that all the angles? Okay, we know that sum of all the angles, take that any figure. Okay, this is theta and here also theta. Why? Because here I taken that all angles are equal. Why? Because that is a regular polygon, that's why all angles are equal. Okay, first I am going to calculate that sum of all interior angles. Sum of all interior angles of a polygon. Okay, already we know that formula. What is that? 2n minus 4 into 90 degrees. That is the formula for to find sum of all interior angles of a polygon, right? Now here in this figure, what are that all interior angles? Here from the figure, theta plus, theta plus, theta plus and so on. Why? Because here I am not saying that this figure is having how many sides. That is just n gone. Okay, this figure is just n gone, which means number of sides is equals to n only, no? That's why here theta plus, theta plus, theta plus and so on. We don't know that up to how many angles are there. So up to n terms are there. Okay, already we know that how to add this all. Addition is, multiplication is repeated addition, no? So that's why here theta is adding up to how many times? N times. So we can write this one as n into theta. We can write this one as n into theta, which is equals to 2n minus 4 into 90 degrees only, no? So which is equals to 2n minus 4 into 90 degrees. Now what they are asking? What is that? Each angle. What is the measure of each angle of a regular polygon? Each angle theta value they are asking. So we need to find that theta value. That's why keep that theta here. So theta is equals to 2n minus 4 into 90 degrees. Here n is in multiplication, so that one become as division. So what is that formula to find that each exterior angle of a regular polygon, that is 2n minus 4 into 90 degrees by n. Okay, so just take here one of the example. Let n is equals to 3. 3 means a triangle. Why always I am taking n is equals to 3 means we know that that is a known figure, triangle. Okay, we know about the triangle, right? That is having 3 sides, 3 angles, sum of all interior angles of the triangle. Okay, we know that, right? That's why I am taking here. So n is equals to 3. Then each interior angle of a regular polygon means that is must be equilateral. Okay, that is a regular figure they are saying. That's why that is must be equilateral triangle. We know that in a triangle, if that all sides are equal, then we will call the triangle as equilateral triangle. So here what is that formula? 2n minus 4 into 90 degrees whole by n. So 2 into n is equals to 3 minus 4 into 90 degrees whole by 3. Okay, so here 2 into 3 is equals to 6 minus 4 into 90 degrees whole by 3. We can cancel 90 and 3 by 30 times. So which is equals to 6 minus 4 is equals to 2 into 30 degrees, which is equals to 60 degrees. So each interior angle of an equilateral triangle is equals to 60 degrees. Just previous only we discussed that, right? Okay, so in this way we can find that any interior angle of a regular polygon. Okay, for example here n is equals to 6. N is equals to 6 means that is a regular hexagon. We will call that figure as a regular hexagon. Okay, then regular hexagon is having that each angle is measures how much angle here. Okay, so again use the same formula, 2 into 6 minus 4 into 90 degrees whole by 6. Okay, so here 2 6 12 minus 4 into 90 degrees whole by 6. So which is equals to 12 minus 4, that is 8 into 90 whole by 6. Is there any cancellations possible? Yes, 2 4s and here and another way also there. So 2 3s, again 3 30s. So 4 30s is equals to 120 degrees. Or else 90 cancels by 6. Okay, 6 1 6 and 6 5 30. Okay, clear? So in that way also we can find. So here each angle is equals to 120 degrees. Okay, in that regular hexagon, each interior angle is equals to 120 degrees. Is it clear? So by using this formula we can find that any interior angle of a regular polygon. Okay. Okay, now see that another one. What is that? Sum of all exterior angles of a polygon. Sum of all exterior angles. Already we know that angles means we have that interior angles and exterior angles, right? So here interior angles already we learned that. Now learn about that exterior angles. So sum of all exterior angles of a polygon is 360 degrees. Okay, how that one we can say? Okay, just say that proof. For example, here this figure is having n-sided figure again. So interior angles I am going to take it as some E, E1, E2, E3 and so on. So here exterior angles I am going to take it as theta. So theta 1, this is theta 2, theta 3 and so on. For example, that is n-sided polygon. Okay, now here from the figure we can say that theta 1 plus E1 is equals to 180 degrees. How? Here theta 1 is equals to E1, theta 1 plus E1 is equals to 180 degrees I am taken here. How it is possible? Why? Because here these two forms here theta 1 and E1, those two are adjacent angles. Those two are adjacent angles and those two forms a linear pair. Already we discussed about this one in elementary geometry, right? So those two forms a linear pair. Okay, so theta 1 plus E1 is equals to 180 degrees. And in the same way, theta 2 plus E2, those two also forms linear pair, right? So next one, theta 2 plus E2, which is equals to 180 degrees. And come to this one, here also same only, no? Those two also forms a linear pair. That is theta 3 plus E3 is equals to 180 degrees, and so on. And so on. Theta n, how many angles? We don't know that. N-sided figure means that is having n angles. N exterior angles are there and n exterior angles are there and interior angles are there. Okay, that's why here also the reason is a linear pair. Now add that all the angles. Add that all the angles. What you will get here? Theta 1 plus theta 2 plus and so on theta n plus E1 plus E2 plus and so on En, which is equals to 180 plus 180 plus and so on up to n times. N times 180 we can add. Okay, so here this equation we got after adding these all angles. Okay, now see this condition, theta 1 plus theta 2 plus and so on theta n plus E1 plus E2 plus and so on En, which is equals to 180 degrees plus 180 degrees plus and so on up to n times. Okay, so here theta 1 plus theta 2 plus theta 3, those all are exterior angles. Here theta is exterior angle, no? So theta 1, theta 2, theta 3, those all are exterior angles. We need to find that exterior only, no? That's why keep that exterior angles in that left hand side. So that is theta 1 plus theta 2 plus and so on, or else in this step only right here we know that E1 plus E2 plus E3 plus and so on, those all are interior angles. So sum of interior angles, sum of all interior angles, what is that formula? That is 2n minus 4 into 90 degrees. Why? Because these all are interior angles. Okay, and we can see here sum of all these interior angles. That's why we substituted the formula as 2n minus 4 into 90, which is equals to 180 plus 180 plus 180 plus and so on up to n times. So we can write this one as n into 180 degrees. Yes or no? Okay, so here theta 1 plus theta 2 plus theta 3 plus and so on up to theta n, which is equals to 180 degrees into n, which is nothing but n into 180 degrees minus total this term transpose into that RHS side, we will get this one as minus 2n minus 4 into 90 degrees. Okay, so which is equals to 180n minus 90 into 2 is equals to 180n and minus into minus or else minus 90 into 4 is equals to 360 degrees. Okay, which is equals to 180 degrees n minus into plus is equals to minus 180 degrees n minus into minus is equals to plus 360 degrees. Clear? So here plus 180 minus n minus 180 degrees n, those two also gets cancelled. So here the leftover is 360 degrees. So which one is equals to 360? Here theta 1 plus theta 2 plus theta 3 plus and so on up to theta n is equals to 360. Okay, what we will call that theta 1, theta 2, theta 3? Those all are exterior angles only, no? So finally we got that sum of these all exterior angles which is equals to 360 degrees. Okay, so hence it is proved. Okay, that's what they given in that statement. What is that? Sum of all exterior angles of any polygon is 360 degrees. Okay. So the next statement is each exterior angle of a regular polygon is 360 degrees by n. Okay, already we discussed about that interior angle, each interior angle of a regular polygon. So and in the same way, in that regular polygon, all exterior angles also equal. Okay, in a regular polygon all angles are equal, we are saying no. So all interior angles are equal and all exterior angles also equal. So in that cases, what is that? Each exterior angle of a regular polygon. Okay, that is how we can find, means here the formula is 360 degrees by n. So here let theta be an equal exterior angle. Equal exterior angle. Okay, so here just take that any other example like this only, take that one of that polygon. So this is a theta and here also theta and so on. Like this one of the figure is there. So here how we can find that, means let theta be an equal exterior angle. So all angles are equal, no? So that's why theta plus theta plus theta plus and so on up to n times. Why? Because here n angles there, no? That's why up to n times. And we know that sum of all exterior angles of a polygon is equals to 360 degrees. Just now only we proven that is sum of all sum of all exterior angles of a polygon is 360 degrees. So here up to n times there. So we can write this one as n into theta. Okay. So which is equals to 360 degrees. So here theta is equals to 360 degrees by n is in multiplication, so that one become as division. So each exterior angle of a regular polygon is 360 degrees by n. Okay, for example here n is equals to, okay, for example n is equals to 4, which is nothing but a quadrilateral, right? Okay, so take that quadrilateral. Here interior angle is equals to 90 degrees, we know that each interior angle. So exterior angle means here exterior angle is there. So these two angles forms a linear pair. So easily we can say that this is also equals to 90 degrees. By using this formula we will get that 90 or not, just say that. So n is equals to 4. So 360 degrees by 4. So 4 9s 36 and zeros. So 4 90s 360. Okay, that's why we will get here each angle is equals to 90 degrees. So yes or no? Here we got that each exterior angle is equals to 90 degrees. So in the same way we can find that remaining angles also for that remaining any other polygons. Okay, like this way we will learn that so many problems in that worksheet 1. Okay.